Hi, my name is Harvey Irwin and this is my submission to Funtech. I've split the lesson into two parts. The first part covering the basics of OOP, so that's classes, objects, attributes and instantiation, and the second part covering inheritance and polymorphism. So let's continue. If we simply scroll to the top and start. So, object-oriented programming. And I'm going to be describing this using Pythons, cats and T. So first of all, what is procedural programming? So, what is a procedure? And this is where I would ask the class for opinions and examples. So for instance, surgery, docking a spaceship, or making a cup of tea, right? Those are all procedures. Now, what do all of these procedures have in common? And again, I would pause to get opinions. But what I'm looking for is that they all contain multiple steps. So each procedure is an instruction made up of many different steps. Now, the next question is, does the order of these instructions matter? Right? So, for instance, what would happen if we opened the docking door last? Well, we'd probably annoy Chewie. Or wash our hands after operating on someone. We'd probably get their insides all horrible and dirty. Right? And you might be thinking, well, what about the cup of tea? What happens if we mess up the order of the cup of tea? We'll still get one. Well, yes, but you'll make me very, very sad. So, the activity of the class. I want you to write a procedure for making a cup of tea. For instance, I take my tea with milk and 15 sugars. Now, don't worry too much about the syntax. I'm not too bothered about what procedures you use or how you code it. I just want to know that you understand what a procedure is. So, for instance, here's mine. And there we go. So you can see here we define our variables. There we fill the kettle with water and boil it, and at the end we add it all together and mix. Now again, in terms of the pseudocode, obviously that wouldn't stand up in an exam, but it's more about getting the idea across at this stage. So that's procedural programming. Now let's stick with the T example. So in what we've just done, we could say that we described our cup of tea by explaining how to make it, right? But instead of that, let's describe a cup of tea by thinking about its attributes. So, excuse me, an attribute is anything that describes or is associated with a cup of tea, with an object. I do apologise. So, attributes. And this is where we would, as a class, have a little exercise where we go through some pictures that I've found and put on this mind mapping software and come up with attributes for it. So the idea of this exercise is that hopefully someone in the class mentions something like orange, which then allows us to have the discussion that that is not really an attribute because it's not general enough. So the correct way of doing that would be colour, and then we could say that colour equals orange. Cool. And then we would go on and say stuff like tail, species, so tail length, maybe, species, personality, and then we could do stuff like favourite food, etc, etc. So, and then we would do that for cup of tea. Now this is an example that's going to keep coming up because I think it's important to have one kind of continuous thread through a lesson like this. So the attributes that I'd be looking for a cup of tea would be milk in, X milliliters, water again in X milliliters, sugar, right, in number of cubes, or however you measure it. I don't actually take sugar in my tea. And temperature. right? And so we're looking for attributes, not methods in this point. So then, similarly for Grogu, we could say, is alien false or whatever. And this is meant to be quite a fun activity, hopefully get some discussion, but also it's meant to teach them that with this, attributes don't just apply to physical objects, right? And to get to thinking about attributes, about concepts. So, for instance, today, right? What are the attributes of today? Well, the date would be the 30th. The temperature, as you can probably tell by my webcam, would be very, very hot. And etc, etc. So, now that we hopefully understand what attributes are, we can talk about classes. So, in object-oriented programming, we describe our cup of tea by making a class for it. Now, a class is a blueprint used to create an object. So, if you think about what we did at the start of the lesson, we gave someone instructions on how to make a cup of tea, right? But instead of that, we're just going to give someone a list, essentially, that contains everything in a cup of tea, along with a list of the things that you can do with a cup of tea. So you can drink a cup of tea, right? So let's have a go in pseudocode. So if we look here, we've got, at the top, we list out attributes for the cup of tea. And at the bottom you can see there is a method to define how to drink a cup of tea. So here we'd pause to have a bit of a discussion on this and make sure that the class is all okay with this. But what's the problem here? What's missing? So what I'm asking the class here is, could we use this in a bit of program? Could we call cup of tea .drink? Well, no, because the attributes aren't defined and none of it means anything. And that's because it's a class. So, an object is an instance of a class. So now we'd pause to discuss this, and then once I got some ideas in, probably won't get it first time, I'd say that the class describes a cup of tea, but an object is one. So we say that an object is an instantiated class. Now, instantiated is quite a big word for 10 to 12-year-olds. I certainly wouldn't have known it at that age. So I like to use the blueprint analogy. So instantiated means that someone has used our tea blueprint to make a cup of tea, an object. So in a class, all attributes are undefined. But in an object, attributes are assigned values. So here we go. We can see cup of tea class up there, right, which is the definition of the blueprint, and then there to the right of it we can see the instantiated version called mycuppa. Now again, something's wrong here. This code's terrible, right? It takes what, 1, 2, 3, 4, 5, 6 lines to create one object. Well, that's rubbish, that stinks. Is there a better way to do this? Well, yes. Okay, so this is where we would talk about the initialization function. So, at the top here, it's all the same. We simply define our attributes, but then at the bottom, we create an initialized procedure, right? And then we have milk input, water input, temperature input, and so on and so forth. So, the thing to note is the difference between the user inputted variables and the class variables, right? Now, as an aside for the person reviewing this lesson, the reason that I'm doing it this way is because Python OOP differs quite a lot from other languages. So I find it's better to teach in pseudocode and then to kind of find the differences and similarities back to back with Python. So bear with me for a second. And then we can see down there, much simpler to initialize the cup of tea. So we'd probably pause here. I might get out my pen to make some annotations or re-go through this to make sure the class is on board. So Was that all a bit confusing? And like I said, this is where we would pause. So, just remember, you can't interact with a class. You can't drink a blueprint, can you? A class tells you about all the things that makes an object and all the things you can do with it, right? So a class will tell you that an object has a colour, but not what it is. You use a class to make an object, and this is called instantiation. And you can then you can then interact with this object to find out or alter its attributes, right? So let's transfer our pseudocode into Python and see what is different and what is the same. Okay, so let's get, whoops, okay, so let's go to Kate and Visual Studios, and I'm just going to copy this, okay, into there, jolly goods, right. Oops, I do apologise. Okay, right. So, class cup of tea. All quite similar now, but this is where it gets different. So, we don't define our attributes here. So, no attributes defined here, right? Where we define our attributes is actually in def init. Now, def init looks quite scary. Certainly to me, the idea of an underscore being followed by an open and closed brackets simply didn't make sense when I was in primary school, so that's okay. But the key thing is that in this we put all the variables that we want, right? So this is where we allow the user to input variables for attributes. So we have milk inputs, water inputs, temp inputs, sugar inputs, do apologise, and tea bag. Okay, cool, I think that's everything, yeah. So those are the user inputs, those are not the attributes. So what we do to create the attributes is we say self dot. So you can see that self has been passed into the initialization function. So to make self.milk, we do self.milk equals milk input, self.sugar equals sugar inputs, self.water equals water inputs, and so on and so forth. And self.tea equals teabag inputs. So you can see now that these and this, hopefully you can see those two are the same. The only difference is, because we're in Python, we don't need to define our variables like this before we use them. Right. But I find that that is quite useful to do in pseudocode conceptually. So, let's go back to here. Okay. So, let's talk about init. So, def init, and I've used two N's, my bads. Def init is called automatically as the initialization method when an object is instantiated. And it's responsible for setting up or instantiating the object. So for instance, at the bottom, you can see that we have my cup of tea, 10, 130 Yorkshire 15, which relates to this, right? So what this is actually calling is init. Yeah, it's calling the initialization function. It just doesn't need to be written like that because it's automatic. So that's the main thing that I want to get across to the kids at this stage, right? Is that the initialization function is called when you do class brackets, when you call a class like that. Okay, so let's talk about self. Now, self is weird because Python is weird. self is not used in basically any other OOP programming language that I can think of. There are certain languages that use this instead, but again, you don't need to, and from how I was taught at least, that's slightly frowned upon to use. Now, self refers to the object you create. So this is quite a difficult concept to get across. So within our T class, if we said milk equals milk.input, all we've done there is create a variable called milk that is then lost when the initialization function ends, right? So if we look here and if we go self.milk, right, if we simply say milk, you can see the IDE itself actually tells us because it's not highlighted, right, because it goes out of the, because once the function ends, the variable is gone, right? So we have to do self.milk because then that creates a object attribute, okay? And so that's probably something I'd spend a while with talking about on the class to make sure they have absolutely nailed that idea. So self.milk, however, assigns the object's milk attribute to the user input milk input. So some rules with self. When creating methods within a class, all class attributes must be prefaced with self, right? So whenever you access milk, teabag, water, anything to do with a class, inside a class function, you have to do it with self. So for instance, if we were to make a drink function and we wanted to, we couldn't do water equals amount, whoops, let me just add amount. So we couldn't do water equals plus equals amount divided by 2, right? That wouldn't work, okay? Because water is not defined, okay? But if we were to do self.water, that is okay. So, and the second rule of self is that when creating a method within a class, self must always be passed as the first parameter. Can't be second, can't be third, or however you want to do. For instance, this will not work because milk input will refer to the object and self will refer to milk input, right? Self has to be first. Now, when you call cup of tea, you don't need to pass self. So if we do this, so for instance, my cuppa equals cup of tea, self, that's not needed. Okay, we can just say start right off with milk input. Cool. So those are the rules of self. Now, those are something that you'll just become aware of as you use it, but it's good to keep those in mind. So, I've just shown you the recreation of the drink method in Python, so let's have a little recap. So this is where I'd go over the class, what's procedural programming and what is object-oriented programming. So, just to make sure that they're very, very clued into their vocabulary at this point. And yes, so that is my presentation on object-oriented programming. There wasn't a ton of Python. I'm going to be doing that mainly in the polymorphism and inheritance, but quite frankly, I find that Python is slightly clunky with object-oriented programming, and that if you want to describe the idea of it, it's best to do in pseudocode and then translate to Python. Anyway, I'll see you in inheritance.